Hello children, welcome to another session of PYQ JEE Advanced. I have come up with a very simple question belonging to the chapter Classification of Elements and Periodicity and Properties. So just look at the question. It's again a numerical question which appeared in JEE Advanced 2020 paper. The first, second and third ionization enthalpies I1, I2 and I3 of 4 atoms with atomic numbers n, n plus 1, n plus 2 and n plus 3 where n is less than 10 are tabulated below. What is the value of n? And you can just see the table there. Look at the table and just compare the ionization enthalpies. If you go to element with atomic number n, the first ionization enthalpy itself is considerably big. You can see 1681 kilojoule per mole. And its second ionization enthalpy definitely should be greater than first. It is higher. And third again still higher. It goes that way. Coming to the second element whose atomic number is just one more than the first element, n plus 1. The first ionization enthalpy is very high. So it's a clear-cut indication that this is an element which is lying to the right, and as you go to the right side, the ionization enthalpy should increase in a period. That's understood to boot. And if you go to its second ionization enthalpy, again it should be higher. It is increased, it keeps on increasing. Coming to the third element whose atomic number is n plus 2, you can see very low ionization enthalpy. Compared to n and n plus 1, the element with atomic number n plus 2, a very low ionization enthalpy. So we get a clue that it may be somewhere in the leftmost. And coming to the second ionization enthalpy is the biggest clue here. The second ionization enthalpy should be higher than first, but you can see a very big, exceptionally big value of second ionization. The difference is too high, which indicates that the second electron must be removed from the penultimate shell, the next shell, not the valence shell. Meaning one electron in the valence shell. The possibility is element with atomic number n plus 2 should be an alkali metal, group 1 metal with the configuration ns1. So that the second electron must be removed from the n minus 1th shell. That is why such a big difference between the first ionization enthalpy and second ionization enthalpy. Coming to the third element, fourth element with the atomic number n plus 3, you can see its first ionization enthalpy is not too big compared to first and second, but it is definitely higher than the element immediately before that, considerably big compared to the element just before that. And very important clue is again its second ionization enthalpy. Its second ionization enthalpy must be higher, but compared to the difference in first and second of n plus 2, the difference in first and second of n plus 3 is not very big. Going to its third ionization enthalpy, you can see the third ionization enthalpy is considerably big, which gives an indication that for the element with atomic number n plus 3, 2 electrons must be there in the valence shell, and the third electron must be removed from the n minus 1th shell, which means n plus 2 must be an alkali metal, group 1 metal. N plus 2 must be an alkali metal, it must be an alkali metal, group 1, first group in the periodic table. Naturally, n plus 3 must be an alkaline earth metal, belonging to group 2. So n plus 1, the element preceding it, n plus 1 must be a noble gas, group 18, and thereby N must be a group 17 element, a halogen. So we started with the ionization enthalpy is 1 and N plus 2 element with atomic number N plus 2, very low ionization enthalpy. So we got a clue, it may be an alkali metal. So we immediately went to its second ionization enthalpy, very big. A clue that it can be an alkali metal, only one electron in the valence shell. We went to the very next element whose atomic number is just 1 greater than the previous element adjacent to it. So its first and second difference should be there, but not as much as in N plus 2. But when you go to the third of this, very big, indicating that 2 valence electron. So N plus 2 must be an alkali metal group 1, N plus 3 must be an alkaline earth metal group 2. So the element just before N plus 2, N plus 1 must be group 18. Therefore, N should be a group 17 element, a halogen. And here it says that N is less than 10. So, halogen with atomic number less than 10 is fluorine, whose atomic number is 9. The question is, what is the value of N? So, the value of N is atomic number of fluorine, which is 9. Thank you, children. Thank you.